This is Spacetime, Series 27, Episode 43, for broadcast on the 8th of April 2024. Coming up on Spacetime, discovery of the faintest known star system orbiting the Milky Way galaxy. Queensland's Bowen Orbital Spaceport officially opened for business. Meanwhile, over in South Australia, Southern Launch are getting ready for their next test flight. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have detected an ancient star system orbiting around the Milky Way galaxy, which has set a new record as the faintest and lowest mass star system ever discovered. The finding, reported in the Astrophysical Journal, has been named Ursa Major 3 Unions 1, and it may well be one of the most dark matter-dominated star systems ever known. Ursa Major 3 Unions 1 is located in the direction of the constellation Ursa Major, the Great Bear, which is also home to the Big Dipper. The study's lead author, Simon Smith from the University of Victoria, says that this star system or galaxy, whatever it is in our cosmic backyard, relatively speaking, and located just 30,000 light-years away. It's escaped detection until now because of its extremely low luminosity. Observations reveal the star system's tiny. It only has about 60 stars that are over 10 billion years old. It's spanning just 10 light-years across, and it has an extremely low mass, just 16 times that of the Sun. That's for the entire system, making it some 15 times less massive than the faintest suspected dwarf galaxy. It was first detected in data obtained by the Union's Ultraviolet Near-Infrared Optical Northern Survey, which is conducted on the Canada-France-Hawaii telescope and on Pan-STARRS. The team then decided to study the star system in more detail, using the Keck Observatory's Deep Imaging Multi-Object Spectrometer DEIMOS, confirming that Ursa Major 3 Unions 1 is indeed a gravitationally bound system, either a dwarf galaxy or a star cluster. The thing is, there are so few stars in the system that one might reasonably question whether or not it's just simply a chance grouping of similar stars. And that's where Keck came in. Its massive 10-metre twin telescopes and DEIMOS spectrometer were able to determine that this was not the case. The DEIMOS measurements clearly show that all the stars in the system are moving through space at similar velocities and appear to share similar chemistries. A tentative spread of velocities among the stars in the system supports the conclusion that Ursa Major 3 Unions 1 is in fact a dark matter-dominated galaxy, a tantalizing possibility which the authors hope to scrutinize with more Keck observations. The big question now is how the stars in the system managed to stay together in such a tight-knit group for so long. And one possible explanation for this is that dark matter is keeping them together. Still, the object's so low mass, its long-term survival is surprising. See, one might have reasonably expected that the harsh gravitational tidal forces of the Milky Way may well have ripped the system apart by now, leaving no discernible remnant. But the very fact that the system still appears to be intact leads to two equally interesting possibilities. Either Ursa Major 3 Unions 1 is a tiny galaxy, stabilized by large amounts of dark matter, or it's a star cluster being observed just before its imminent demise. With the former scenario, achieving direct confirmation that Ursa Major 3 Unions 1 is a faint, ancient dark matter-dominated satellite star system would be important, as it would support a prediction in the leading theory of the universe's origin. You see, under the Lambda cold dark matter model, which is the preferred and accepted model for the universe right now, astronomers hypothesized that when galaxies like the Milky Way first formed, they created a gravitational pull during their assembly process, and that attracted hundreds of satellite star systems which continue to orbit the galaxies today. The authors say this discovery could be the tip of the iceberg. It could be the first example of a new class of extremely faint stellar systems which have eluded detection until now. Conclusive evidence for the presence or lack of dark matter in Ursa Major 3 Unions 1 will be key in determining whether the star system is a dwarf galaxy or a star cluster. Until this classification becomes clear, Ursa Major 3 Unions 1 will continue to have two names. See, ultra-faint Milky Way galaxies are typically named after the constellation they're discovered in this case Ursa Major, hence the name Ursa Major 3. Whereas ultra-faint star clusters are generally named after the survey project which discovered them, in this case Unions. While the star system's identity is still ambiguous, Ursa Major 3 Unions 1 paves the way for a new perspective on cosmology. Smith says the discovery may challenge science's understanding of galaxy formation, and perhaps even the definition of exactly what a galaxy is. This is Space Time. Still to come, Queensland's Bowen Orbital Spaceport opened for business. Meanwhile, over in South Australia, Southern Launch are getting ready for their next test flight. All that and more still to come on Space Time. Australia's first privately operated orbital space launch facility has been formally opened at Abbott Point near Bowen on the Queensland tropical Pacific coast. The complex is expected to undertake its first launch next month, with the Gilmour Space Ares rocket to undertake its maiden flight. The 23-metre-tall 35-tonne three-stage Ares rocket is capable of launching payloads of over 300 kilograms into a 500-kilometre-high low-Earth equatorial orbit. The Ares Block 1 launch vehicle contains a hybrid propulsion system for its first and second stages and a liquid propulsion system for its third stage. Gilmour is one of only 3 launch providers in the world to have their own dedicated launch sites. That'll ensure a constant launch cadence once the rocket successfully achieved orbit. The Bowen Orbital Spaceport will launch eastwards over the Whitsundays. Ares Test Flight 1's targeted to launch in coming weeks, pending final approval and a launch permit from the Australian Space Agency. Gilmour Space CEO Adam Gilmour is predicting a bright future. He says there aren't enough rockets to take up the tens of thousands of satellites now looking for launch windows in the next 5 years, and Ares will help close that gap. Of course, in a way, all this is sort of déjà vu. See, Australia became the third nation on Earth to launch a locally built satellite from their own soil way back on November the 29th, 1967. The only ones to achieve the feat ahead of Australia were the Soviet Union and the United States. Back then the spacecraft launched was the Weapons Research Establishment satellite RESAT, which was launched from the Woomera rocket range in outback South Australia. Woomera is still there and it's still launching rockets, but it's mainly used as a military test facility. But back then, at the time of the RESAT launch, Woomera was the second busiest spaceport in the world after Cape Canaveral. Of course, that launch back in '67 was aboard an American Redstone Sparta rocket, which was developed as part of a joint Australian, US, UK space project. Ares, on the other hand, is the first Australian-made rocket specifically designed to launch commercial satellites into orbit. Only 12 other nations have their own orbital launch capability, and Gilmour Space plans a series of launches with the aim of becoming Lucky 13. Of course, when you think about it, space is hard. It took SpaceX, now the most successful launch operator in the world, 4 launch attempts before they were able to achieve their first orbit. Ares lead mission manager Matt Congetti says with the spaceport now open for business and the Ares rocket fully assembled on site, the countdown to launch is underway.
It's been a great period for us. We've kind of come through the bulk of our kind of preparations. We've had a pretty dedicated team up there for a couple of months now, and they've been working on a variety of things. The rocket's been up there undergoing a bunch of testing, but probably the most kind of consequential thing that's happened up in Bowen is we've actually been approved for our launch facility license, which is the first of its kind in Australia. So that allows us to launch our Ares launch vehicle up into orbit, and it's really the first commercial orbital launch facility license that's ever been granted in Australia. So our team up at the launch site have been working for a really long time with the Australian Space Agency to give the agency the confidence that we're capable of operating the facility and give us a really good pathway into the first launch.
And at this stage, is that still likely to occur this year?
Yeah, absolutely. We're kind of starting to close in on some of those final activities necessary for us to get to that first launch. So we're targeting over the next kind of month or so. So a lot lot of the outstanding actions in relation to getting to that first launch are associated now with the launch vehicle. Obviously, our facility, the launch facility itself at the Bowen Orbital Spaceport, is now ready to go. So a lot of those kind of final activities are in relation to the launch vehicle. We're doing a lot of those kind of final testing activities. We call them verification activities. We do a lot of testing on the launch vehicle, either at the subsystem level or then assembling it all together and doing that testing at the system level, and then commissioning all of the ground launch systems that are required to facilitate the launch over the coming period as well. So we're in that kind of closing period now, doing a lot of those final checks in preparation for the launch, and then also working with the Australian Space Agency to get we've got the launch facility license, but we also need an Australian launch permit to allow us to get to that first mission. So we're working very closely with the Australian Space Agency to close out a lot of those action items.
So exactly what is there at Bowen at the moment?
We've got most of our equipment that's necessary for the launch is up there at the moment. So in addition to all the people, the rocket itself is up there. We've obviously got a variety of different areas around the Bowen Orbital Spaceport. Comprised within that is kind of the vehicle assembly building, where we do a lot of those testing activities, where we configure the launch vehicle for that flight. And then we have, in kind of adjacent to the vehicle assembly building, we have what we call, it's a big raceway that leads down to the launch pad. And then at the end of that launch pad is what we call our ground launch system, which has a giant fluids tower, which allows us to engage directly with the rocket when it's in the vertical position. We have a giant transport erector, which we've designed, which allows us to take the rocket from the horizontal position up into the vertical position. And then in addition to that, we have a variety of equipment that allow us to speak with the rocket when it's either on the pad or during the mission when it's in the flight. So to do that, we have a launch control center, which is located several kilometres away from the actual launch pad itself, allowing us to be at a safe distance during the launch countdown and during the mission. And that allows us to control the rocket directly from a safe distance, whilst also making and monitoring, allowing us to monitor the launch vehicle and all the systems on board the vehicle to make sure that everything is going to plan when we are kind of conducting that launch countdown.
Do you have your own weather station, or do you rely on BOM? How does all that work?
It's a bit of an interesting relationship. We try and do as much as we can ourselves, but obviously this is an activity that requires us to engage with a whole bunch of different stakeholders throughout industry, whether they be regulators at different spaces, whether they be the BOM. So we're releasing as many kind of weather radio sonde balloons to gather data about the environmental conditions and the weather to inform our go, no-go criteria for the rocket. Obviously, that's a crucial part of that final decision to launch. And then in addition to that, we're kind of engaging with a whole host of different stakeholders. We're engaging very closely with the BOM, who are providing weather prediction models that we can use to inform what days are going to be good or not so good for launch. We also engage quite closely with some of the surrounding aerodromes and airports that have been collecting data for a long time. So we use that data in our assessment of availability of the launch vehicle. How many of the days are we expecting to have good weather conditions versus not so good weather conditions? And we factor that into our assessment of a given flight's safety to make sure that when we do eventually commit to that launch, all of those weather conditions have been factored into the safety picture, making sure that we're not posing any risk to third parties.
And tell us about the Ares rocket itself. The launch pad's been specially designed for that rocket.
So the rocket is the first of its kind in the world. It's a 3-stage rocket. Each stage does its job and then returns back to the Earth to leave the other stages to progress to space. It's a new kind of technology that's never been put into orbit before. So it's a hybrid rocket, and that means that it has a liquid oxidizer paired with a solid fuel grain, and that results in a configuration that's much less explosive, much less likely to react on the pad and create explosive anomalies or anything like that. Makes it a lot safer. And the intent of the rocket is really, it's a commercial launcher. So it's the first of its kind to attempt to reach orbit, and eventually over time we'll start to be servicing commercial customers, commercial entities who are looking to deploy a satellite on orbit and establish their capability in space.
With a hybrid system like this, can you control throttle performance during the launch, or are you sort of, like with most solid rocket engines, committed to full power all the time?
It depends. Generally, we'll have a set profile that we'll look to follow. So we'll generally just throttle it up to a maximum. But throughout the mission, we do have the ability to terminate thrust at any point in time. So generally speaking, we'll just throttle it up to the maximum capacity that we deem necessary for that particular mission, extract as much energy as we possibly can throughout the duration of a first stage or second stage burn. And then there are some caveats to that in terms of how the vehicle will perform over time as it uses up some of that propellant to facilitate control of the launch vehicle. So there is a little bit of variability there, but generally speaking, we do throttle it up to the maximum.
What about payload capacity? How much can you lift and and how high can you go?
It really depends on the conditions of the day. During the mission, the wind conditions, and what we do is a kind of wind biasing, which will allow us to control the rocket to different margins. It also depends on the inclination that we're looking to hit as well. So the closer you are to the equator and the closer you are to following the Earth's rotation, the more capacity you're able to produce because you're getting an extra little boost from the Earth. So at the moment, we're targeting quite a modest kind of payload. We're looking to put up roughly 100 kilos or so to 500 kilometers for our commercial customers in the coming missions as we start to service those commercial customers. And over time, we've got a pretty steady growth path of performance improvements that we're looking to add to the vehicle. And those performance improvements are going to address different things on the launch vehicle. Some of it's going to be related to reliability, improving the reliability of the launch vehicle, and some of it's going to be related to performance, putting more mass higher up in orbit and servicing different missions of our potential customers.
How does what Gilmour Space are doing at Bowen differ from what's happening, say, with Southern Launch or with Equatorial Launch Australia?
Yeah, so we have slightly different business models. Each of us are kind of targeting a different segment of the market. So Gilmour Space's primary focus is on kind of developing our own launcher and launching it ourselves, whereas Southern Launch and Equatorial Launch Australia are rather intending to be the service provider and the launch facility provider to overseas customers who want to launch their own launch vehicles. So our business is very much more directed towards servicing the satellite customers themselves, and we do that by providing a comprehensive package. So that comprises of the launch facility from which you are able to launch, as well as the launch vehicle, as well as all of the associated services that are necessary to get a satellite up into orbit. So we will support a customer through their design process and qualification process, making sure that they're well equipped and ready to fly on our launch vehicle. And so it's kind of an end-to-end comprehensive service for a satellite customer who really, at the end of the day, just wants that capability up in space, on orbit, addressing the problems that they're seeking to address.
It sounds very much like a similar model to what Rocket Lab have with their Electron out of New Zealand.
Yeah, look, there's certainly similarities across the industry. We do feel that there's really room for everyone at the moment. There's a real bottleneck in the launch industry for people who are looking to get capability up on orbit. Different launchers operating from different launch sites have access to different orbits as well. So there certainly seems to be room for everyone with the kind of bottlenecks that we are seeing in the industry. We're hearing reports of individuals and satellite operators who are having to wait years and years to get onto certain missions that they're looking to get onto. And if we can support them in hitting those mission objectives sooner, then that's great.
That's ARES lead mission manager, Matt Congetti. And this is Space Time. Still to come, Southern Launch getting ready for their next test flight, and later in the science report, warnings that Australia could soon see mega droughts lasting more than 20 years. All that and more coming up on Space Time. Southern Launch says its Cunibba test range on South Australia's Eyre Peninsula is almost ready for its next launch in just a matter of weeks. The test flight will see the launch of a German Heimpulse 75 rocket, which will test the new hybrid propulsion technology by combining paraffin wax and liquid oxygen, resulting in a non-explosive fuel, at least until you mix the two and ignite them, that will revolutionise rocket handling and logistics. The test flight's slated for either the end of this month or early May and will launch to an altitude of around 50 kilometres before parachuting back to the ground, where it will be recovered for testing. It's hoped the test will assist the builders developing their larger SL-1 orbital launcher. The Cunibba test range is located northwest of Ceduna and has been equipped with a transportable rocket launcher for this project. The range provides space companies with the unique ability to launch and land their vehicles on the same range facility. That enables them to recover their technologies and analyse the system's performance. It also enables suborbital missions to the edge of space to conduct experiments, and it can support the re-entry of space technology from orbit. This makes Cunibba different from Southern Launch's planned new orbital launch complex at Whalers Way. The orbital launch project near Port Lincoln on the tip of the Eyre Peninsula will focus on space launches over the Southern Ocean, aiming for polar orbits. Of course, this won't be the first launch from the Cunibba test range. DWAC Systems conducted a series of launches back in September 2020. A sounding rocket containing a small replica payload was slated to launch on September the 15th, 2020, with a second launch on September the 19th. The missions were designed to collect information to develop new electronic warfare technologies focusing on CubeSats. And while the first launch failed, 2 successful launches were conducted 4 days later. Southern Launch claims it's got several missions on its books to launch from the new Whalers Way site, including the REFEX mission with the German space agency DLR. The company says it's also signed a memorandum of understanding with UK-based Spaceforge to use the Caniba test range as a re-entry point for their spacecraft, alongside a separate deal to use it as a re-entry point for a capsule undertaking pioneering medical experiments in space. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Australia could soon see mega floods lasting over 20 years. That's the grim warning by scientists at the Australian National University based on their latest computer modelling. And worse still, the bleak findings reported in the journal Hydrology and Earth System Sciences don't include the amplifying effect of human impact on the climate since the Industrial Revolution. The study found that 20th century droughts in southwestern and eastern Australia, including the Murray-Darling Basin, were longer on average compared to pre-industrial times. Of course, mega droughts would be exceptionally severe, long-lasting and widespread. They're able to last for multiple decades, even centuries. The study's authors warn that if a mega drought did occur in Australia today, the consequences would be made even worse because of climate change, as any drought would occur against a backdrop of hotter weather. One of the problems with understanding protracted droughts in Australia is that climate observations since the 1900s only really provide a handful of examples to work with. Therefore, they're not representative of what could be a worst-case scenario that's possible through natural climate variations. The authors think a mega drought could be occurring in Australia every 150 years. The researchers used multiple climate models to simulate droughts that occurred during the past millennium in order to determine how they might change in the future. This includes predicting how long Australian droughts could last for and how dry they could get. The authors say we can reduce the impact of future mega droughts by being prepared, lots of water storage, good management plans, and a major community support network. A new study has found a strong link between Alzheimer's disease and the daily consumption of meat-based and processed foods. Researchers at Bond University came to their conclusions after examining the diets of 438 Australians, 108 with Alzheimer's and 330 in a healthy control group. A report in the Journal of Alzheimer's Disease found that those diagnosed with Alzheimer's tended to regularly eat foods such as meat pies, sausages, hams, pizza and hamburgers. They also consumed fewer fruit and vegetables, things like oranges, strawberries, avocado, capsicum, cucumber, carrots, cabbage and spinach. A new study claims that while the earliest dinosaurs experienced rapid growth rates, so too did many of the other animals living alongside them. The findings, reported in the journal PLOS One, examined patterns of bone tissue and fossilized leg bones of an array of animals in one of the earliest known Mesozoic ecosystems found in Argentina and dating back to around 231 to 229 million years ago. The analysis found that most of the examined species had elevated growth rates. These were more similar to modern-day mammals and birds rather than to living reptiles. The findings support previous research which suggests that fast growth was an important feature for dinosaur success. However, since other animals were also growing fast, the authors say the rapid growth is only one part of the story of the dinosaurs' eventual global dominance. A new survey claims that some 76% of people really do believe in psychic abilities. Tim Mendham from Australian Skeptics says, while that may seem awfully high, it should be taken with a grain of salt, as the survey itself wasn't really undertaken in a truly scientific way.
Fascinating, actually. This was a survey done, I think, in the UK of 400 participants, and we'll get later on to some issues with the survey, but the results show that 76% believe in the existence of mediumship and psychic abilities. 59% think that everyone possesses such skills, some degree of psychic ability. 64% of the respondents said they've attempted to develop their own psychic abilities, and 58% feel that they possess them, though a notable 25% are unsure. There's a whole lot of theories and statistics in this. One of the problems with this survey was it was done online. This is reported in a website. It doesn't say they did it, right? But it's reported in the website that has a certain leaning towards the believing, even though at the same time it's actually called Higgy Pop. It actually does have some sort of reasonable skeptical stuff at the same time, but it covers a lot of the paranormal in this website. The trouble is, it's an online survey, so the ones who are responding to it are the readers of, or the followers of Higgy Pop, who would tend to have a bit of a stronger belief anyway, and those who can be bothered filling in an online survey, which would probably be those who are more inclined to have a positive view of these things. And one of the issues is that the survey is still open, even though they publish the results. You do not do that in a survey, because then people can then write in and change the results. If you want to get a bevy of skeptics to write in and say, it's all rubbish, you can skew the results one way or the other if you have a lot of believers, if you gather everyone together and say, we're going to fill in these forms online. So, yes, I would suggest that the numbers you should be very cautious of, very, very cautious, because it is only a small survey. 400 doesn't seem to be not a lot of people for this sort of thing. And that the audience is more inclined to believe these things than not. So, I mean, it's really, as much as I like Site Higgy Pop, it's quite fun. This is not a survey to believe, because it's so many red flags popping up all the way about this survey. But, the numbers are interesting. People will quote them. Even the way they organise the questions is sort of dodgy. Like, when you're talking about how accurate are psychic predictions, etc., the options are very accurate, more than accurate, accurate, partly accurate, or not at all. So, in other words, 4 of them would suggest that there was an accuracy there of some level, right? So, the results tend to lean towards sort of being accurate because of the way the questions are asked.
That's Tim Mendham from Australian Skeptics. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.